Welcome back to the lab. Now, I know it's been a long while since we talked about the UPS project, longer than I would like, in fact. It's just, yeah, it's been a crazy time, holidays, getting through, kicked off a new series, we're getting back to basics, talking about comparators, but we're doing cool things, okay? We're doing cool things, and today I'm really excited to show you something. Yes, right, I should probably... Yes! We got some stuff. Okay, step one, we got some stuff. And you'd probably love to see the pile of magnetics. Yeah, I'll get to that in a minute. But if you've been with the channel for a while, you'll know what you're looking at here. What you're looking at is the UPS Phase 2 main board as assembled by JLC PCB. One of our daughter cards, either the I don't know which one that is, and then this is the other daughter card. So we've got a battery daughter card, or then we got an inverter daughter card, a battery daughter card, and a main board. And we don't really have any structured content around this. I mean, for those that have been watching the channel, you'll know there's a lot of work that is going to go into finishing these. This isn't going to be a turn and burn one video hour of work. Like, this is going to take some time, but we're going to work through it, and I wanted to kick that all off today by just sharing some of my excitement, doing an inspection of the work that JLC PCB did. Let's see, there's so much that I want to say. Okay, so this is a 4-layer board that we had them assemble. It's Hazel surface finish, one side assembly. We only had them do their library parts. We didn't have them do any of the specialty parts. Yeah. This means we've got to put on our micro. That's basically an Arduino do. We've got an Ethernet PHY that's over here and some ports off on the left. And then there's the high voltage bus down the middle that can carry about 40, 50 amps worth of 600 volts DC. There's a lot of power we can push through this board. These four all look great. Like, the solder mask has excellent consistency. The solder mask has excellent consistency. The silkscreen looks fine. Yeah, routed slots all turned out okay. The boards seem very level, which means that, well, holding it up to the light, they didn't add any thieving. They didn't add any thieving, which is great because of the isolation we've got. Looks like we've got an appropriate amount of spacing. And yeah, they all look the same to me. So I'm going to keep one of these out, and I'm going to put the rest of these away. Ooh, wait, there's a little something. There's like a scratch here. Looks like there's an abrasion. Probably when they were depaneling or something. Man, these boards are massive. To give you a wholly unscientific idea, I mean, that's 12 inches for scale. This board is almost a square foot. And yeah, we used the same form factor as last time. We used the computer motherboard ATX standard, but in fact that wasn't enough this time. This silkscreen line that you're seeing along right here, yep, that is the edge of a standard ATX motherboard, and we've got this inch and a half tumor hanging off the side. It really is a beast of a motherboard. I don't remember all the statistics on this. Cost a few $100s to get it assembled. Actually, no, it was about $100 total, all told. This is about $100 for assembly, components, and the raw fab, 4-layer, delivered. So this is Hazel, it's not Enig, but the through holes look great. We've got the microscope here. We're not going to go super overboard with this, but I just want to give you an idea of the quality of what we're getting. So So you can see the through hole. Let's grab a tweezers so we can point a little bit. One of the things that we noticed on our all PCB boards was some tears in that surface finish along the inside there. These look great, but the nature of Hazel is that there's solder that's flown in there, and it'll kind of fill in all the gaps, so it might not be quite right. It might look a little better than it truly is, and that's okay. The drills do look fairly good though. I want to zoom in a little bit on some of these PCIe card features. Those look very consistent. That's good. Yeah. Yeah, the drills look fine. They're wholly acceptable. The only one that might be a little different over here is we've got some routed slots. Those are looking fine to me. I don't know about you. Oh, yeah, we can see a little bit. You can see a little bit of surface roughness inside of there. Like right in that corner, the reflection's not perfect. But that's okay. A lot of board houses would charge for routed slots, and they didn't. Yeah, you see a lot of the typical surface finish of a Hazel board, kind of that grainy, not super level. But yeah, I mean, it looks. Here, I think we're a little too close to the sun. I mean, that's 0.5 millimeter pitch. These traces are pretty darn close together, and still 6 mil tracing space. I think they're 10 mil traces. When it comes to actually soldering the parts on the board, and they look fine. It's a lead-free surface mount assembly. Yeah, I stand by it. We gave JLC PCB a second shot, and in my opinion, this board is a lot more complex than our temperature monitor project. This is a much bigger challenge to pull off, right? This is a big board. It's not the most complex, doesn't have a whole lot of controlled impedance or anything like that. But yeah, everything looks nice and level, consistent, centered on the pads. Ship it. So I guess, yeah. Next steps will be getting all the through hole and ICs and everything else populated. Cool. Who wants to see? Alright, we've got a different beast this time. We have a different animal, and that is ENIG. So it's Electroless Nickel Immersion Gold. That's what ENIG stands for, and we had to do that because these gold fingers down here. This is our battery daughter card. It is also massive. Finding a chassis to install this on is going to be tricky. It's about 16 inches long and about 8 inches tall. It's a beast of a PCIe card. And if we flip it over, you'll start to see why, right? Giant capacitors, giant inductors, giant transformer, giant heatsink. It's just, there's big components on the board. And there's some little stuff in the middle, but like that's not really why it's so big. That's cool. That's cool. Logo turned out good. We added some keep outs in the solder mask, so if we need to tin this and add like some tin copper wire, or just add some copper for additional, or add some solder for additional current carrying, we can do that. On a high level, this looks okay. If I catch the light just right, I'm seeing some abrasions on this board as well. But nothing too bad. How about this one? Ooh! This one's got some nasty battle scars. Yikes! Ooh! Okay. I guess this will be the board that we use for the inspection. Oh, it just breaks my heart. Look at that. Oh. Yeah, that's not what you want to see. Some kind of sharp thing. It was put down, probably dropped onto something, and then slid. And that goes pretty much all the way across the board, comes over this component pad. That's not what you want to see. Considering the cost, I can't be too mad, but yikes. Looks like that didn't only happen once. Looks like, yeah, there's some other battle scars. That's not great. That's probably a piece of my hair. That's probably not their fault. As far as the actual surface finish, looks fine. Solder mask, silk screen, routed slots, the component assembly. Yeah, I mean, the board looks fantastic. And yeah, the amount of time this saves is incredible. Dropping a couple ICs, even if they're, you know, tiny. I don't know. Here's a SOT 23 for scale. That's a SOT 23 for scale. That's a pretty small part. That's a very small part. QFN, but that's fine. Yeah. Quite good. Yeah, this is something that I've always thought was kind of weird about JLC PCB's process, and this might just be an everywhere thing. It might be there. I don't know specifically what they're using. If they're using some kind of like printer or what, but I've always noticed if you've got a big pad of silk screen, it kind of looks grainy and limey. It's a little weird. Oh my goodness, more abrasions. Ugh, it just makes me cringe. Ugh, it just makes me cringe. Ooh. And the surface roughness. Yeah, it's not great. I don't know. I'll have to double check the IPC standards. I don't know if that's actually a problem. No, it's just roughness. It makes me very uncomfortable, but I'm not sure that it's actually a defect. Got one more set of donor cards. Oh, JLC PCB, come on. Some kind of sticker. Well, at least it's not on the gold fingers, but gross. Looks like there's also some kind of abrasive damage to this board. I'm using the light to try to catch some of that. But overall, plating looks good. The coverage of solder mask looks great. Oh, by the way, this was a point of discussion. I'd mentioned that I was a little nervous about this. Got a little bit of encouragement from the community. I guess we'll see how it... Oh, dang. Sorry, before we move on, there are two things that I want to call out. So, this board has two things that the other one did not. It has thinner traces, and it has a BGA. And it looks like we have a failure of solder mask. Look at that. Every single one of those traces is not covered by solder mask. There's clearly gold coloring. That's not great. I think that is a 4 mil trace, because if we get over to the BGA, in order to maintain spacing as we're breaking out this BGA, we had to do that. We needed to use the smaller traces. So there are some tiny little pads. Ooh! There's some tiny little pads in there. Yeah. So we see that failure on a lot of those little traces. And coming over here, this one bothers me a lot more. Doesn't that... Oh, sorry. So you got the same kind of deal where there's a lot of these without... But then, ooh! Something got drug across these unprotected traces and like smashed through the plating, and it just exposed some bare copper. Eek. And then on these where the mask was intact, it flaked off the mask and yeah, that's not great. You know, it's like, I suppose, yeah, it would pass an electrical test, it'd pass an e-test, but like, you can't ship this in a product. Like, you couldn't sell these boards as a first prototype. Sure, I'm probably gonna keep using them as a proto house because, hey, they treat me well and the boards are good enough. But like, man, if you really wanted to sell this thing, I just don't know. I don't think this is good enough. Is that fair? Do you guys think I'm being too harsh? That feels fair, right? You know, it's like, you can't have gouges out of your fabs. You can't just have mask flaking off, and you just can't. Like, geometrically, can't really capture this too well, but holding it up to the light, I can see they honored my creepage and clearance. Oh! I spec'd my own tooling holes this time. Yep, I spec'd my own tooling holes and fiducials, so they didn't add them. There is a I'll add it button. Gold fingers look good. They chamfered the edges the way that they should. See if I can get a close-up of that. Chamfered edge. There it is. Solid. I think these will work great. I am really stoked on this. Yeah, I guess, where does that leave us? First of all, I hope you just enjoyed taking a look at these boards. I don't know if, it feels more vloggy than anything, you know. We're gonna work on it. This VGA is incredibly small. There's so many pads. I think it's 120 some pads. It's less than a ½ inch in either direction. Oh, wee. Never soldered a VGA by hand before. We'll see how that goes. I'm thinking I'm going to take the flux. Yeah, I'm just going to throw some flux down there, heat it up, and we're going to see what happens. I think that strategically I will put that part on first, so we know that all the other nodes should be an open circuit or resistive. If we do a diode check, we can check to make sure all the pins are connected to the internal protection diodes, which would tell us that we have a good solder joint, or at least a solder joint. I don't know if it'll be good, but it'll exist. Yeah, this is the smallest I've ever pushed them. I've never pushed them down to 4 mil trace before. They did it. They have 4 mil trace, and that's the smallest via, so we're using their smallest via and their smallest trace allowed on a 4-layer board. Looks like they pulled it off. So, yeah. Yeah, that's all I really have for today. Really excited to dive into this. Really excited to do the final assembly and share the rest of this journey with you. I am so excited to build these hunks of power electronics and figure out if they're gonna work or not. Like, got an output EMI filter. Like, man, I really think this could be the last UPS we ever need to build. I think we might have done it this time, and that brings me a lot of excitement. Yes. Well, if you enjoyed this video, let me know by hitting that like button, getting subscribed, or leaving a comment down below. Coming up soon, we're going to be continuing on our educational journey of the comparator analysis thing. We're walking through some fundamentals of circuit analysis. It's pretty fun, and then we'll be switching gears. Once we get this more in order, we're going to be doing some bring-up testing of the UPS. Boards are in hand. Things are moving. I am excited. Well, thank you all for being here. Thank you all for watching. Thank you to those who have decided to support us through Patreon or some other means. I really appreciate you guys. And thanks for watching. We will see you in the next one. Bye.